This is section 7.2 and 7.3 of Honors Algebra 2, the quadratic formula and the discriminant. The quadratic formula, as we derived in class the other day, says that if ax squared plus bx plus c equals 0, so you have some quadratic equation with coefficients a, b, and c, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to memorize that formula. And that's useful because it can solve any quadratic equation. So we now actually have 4 ways of solving quadratic equations. Number 1, we can factor the quadratic equation if that's possible. Some quadratic equations are factorable and some are not. Number 2, if we have a quadratic equation in this form, ax plus b quantity squared equals some number c. So if we've got a perfect square on the right, or on the left-hand side, then we can take the square root of both sides, but we can't forget to put the plus or minus on the right-hand side when we take the square root of c. So those are 2 special cases. We can factor it if it's possible, or if we happen to have one where it's a binomial squared equal to a number, then we can take the square root of both sides. Those only work in some cases. The last 2 will always work. We can always complete the square, which we learned in class the other day. That is easiest when the number in front of x squared is 1, and when the number in front of x is an even number. That is when completing the square is easiest to use, but we can always use it. We just might have to deal with fractions. Or we can always apply the quadratic formula. That always works. You just have to have the quadratic formula memorized and plug things in and simplify. The part of the quadratic formula that is underneath the square root, the b squared minus 4ac, is called the discriminant of the quadratic equation. And the discriminant tells us how many and what type of solutions we will have for our quadratic equation. And the solutions of a quadratic equation are called roots. So if we just look at what's underneath the square root of the quadratic equation, if we just calculate b squared minus 4ac, we can tell how many solutions we will have and what kind they will be. So here's how that works. If the discriminant, b squared minus 4ac, is positive, if it's greater than 0, then there are 2 unequal real roots. 2 roots that are not the same, they're unequal, and they are real numbers. Real means it could be rational or irrational. So if it's positive and a perfect square, then we are able to factor the quadratic equation, and we will get 2 rational roots, 2 roots that can be written as fractions. If it's positive but not a perfect square, so if it's a number that we can't take the square root of and get an integer, then we get 2 irrational roots, 2 numbers that cannot be written as fractions. They will be the square roots of non-perfect squares. If, on the other hand, b squared minus 4ac, the discriminant, is equal to 0, then we get 1 real root that we call a double root, because it will show up twice. If b squared minus 4ac is less than 0, so if it is negative, then there are 2 conjugate complex roots. 2 roots that are different from each other, but they are related to each other. They are conjugates of each other. So the sign in front of the imaginary term is opposite. So here's some examples. We'll see an example of each of these different types. Our task is to solve it, but before I solve it, I'm going to find the discriminant so I know what kind of solutions I'm looking for and maybe how I should solve it. So x squared plus 6x minus 2 equals 0. The discriminant, remember, is b squared minus 4ac. b is the number in front of x, that's 6. We've got 6 squared minus 4 times a, that's 1. That's the number in front of x squared. If there's no number there, it's always a 1. And then c is negative 2. Okay, 6 squared is 36. Negative 4 times 1 is negative 4 times negative 2 is positive 8. So 36 plus 8. And 36 plus 8 is 44. So 44 is a positive number, and it is not a perfect square. That means I will get 2 unequal, irrational roots. So 44 is positive, but it's not a perfect square, so that means they are irrational. So I can solve it and discover what those 2 unequal irrational roots are. I'll solve it using the quadratic formula because it was not a perfect square, so I can't factor it. I could complete the square, but I'm going to use the quadratic formula. X equals negative b, so that's negative 6, plus or minus the square root of b squared minus 4ac, but we already know that's 44. We've already worked that out. All over 2 times a, 2 times 1. Okay? So negative 6 plus or minus the square root of 44. We can simplify. 4 goes into 44 11 times, so it's really the square root of 4 times the square root of 11. And the square root of 4 is 2. So 2 times the square root of 11. All over 2 times 1, which is 2. So this means that both the negative 6 and 2 square root of 11 are being divided by 2. So I can cancel the 2 into both of them. I cannot cancel it into just one of them. I get negative 3 plus or minus the square root of 11. Those are my 2 solutions. I state my solutions as a solution set. Negative 3 plus the square root of 11 and negative 3 minus the square root of 11. Those are my 2 unequal, irrational roots. They're irrational because I've got the square root of 11, which is not an integer. Number 2. 3x squared minus 7x plus 5 equals 0. Let's find the discriminant. Let's find b squared minus 4ac. b is negative 7, so negative 7 squared minus 4 times 3, which is a, times 5, which is c. So negative 7 squared is positive 49. It's going to be a minus. 4 times 3 is 12. 12 times 5 is 60. And 49 minus 60 is negative 11. So I got a negative number. If I got a negative number, that means that I have 2 complex conjugate roots. 2 complex roots which are conjugates of each other. So let's find out what they are. X equals negative b is negative of negative 7, so positive 7, plus or minus the discriminant, the square root of negative 11, all over 2 times 3. So x equals 7 plus or minus, well, the square root of negative 11 is the same as the square root of 11 times the square root of negative 1. And we know the square root of negative 1 is I. This is the same as I times the square root of 11, all over 6. I could write it like this. 7 over 6 plus or minus I times the square root of 11 over 6. That's acceptable. And I write my solution set as 7 over 6 plus I square root of 11 over 6, comma, 7 over 6 minus I square root of 11 over 6. Those are my 2 solutions. One with the plus, one with the minus. Notice they are the same other than that sign, so they are conjugates of each other. And they are both complex numbers. Those are my 2 complex conjugate roots. Number 3. 2x squared minus 13x plus 15 equals 0. Let's find the discriminant. b squared minus 4ac. b here is negative 13, so negative 13 squared minus 4 times 2 times 15. Okay, negative 13 squared is positive 169. It's going to be minus 2 times 15 is 30, and 4 times 30 is 120. 169 minus 120 is 49. That's a positive number, but it's also a perfect square. 49 is 7 squared. That means that I can factor my quadratic equation. And I'm going to end up with 2 unequal rational roots. So let's find out what they are. If I can factor it, let's go ahead and do that. Remember how to factor like this? Of course you do. You take 2 times 15, which is 30, find factors of negative 30, factors of positive 30 that add together to give you negative 13. How about negative 10 and negative 3? You divide one of those by 2. How about the negative 10? So that gives you negative 5. You're going to use negative 5 and negative 3. You divide one of them by 2, so you have a 2x. The other one's just an x because you didn't divide by anything. The number you got when you divided by 2 was negative 5, so that goes opposite the 2. The other number is the negative 3. So 2x minus 3 times x minus 5 equals 0. That means 2x minus 3 equals 0, or x minus 5 equals 0. So 2x equals 3, and x equals 3 over 2, or x equals 5. And those are my two solutions. 3 over 2, comma, 5. Notice, 2 unequal rational roots, just as the discriminant told me there would be. And example number 4. X squared over 4 minus 5 over 2x plus 25 over 4 equals 0. Let's clean this up a bit. I can multiply everything by a common denominator. How about 4? And that'll clear the fractions. So I'll multiply everything, including the 0, by 4. So I've got x squared over 4 times 4, that just gives me x squared, minus 5 over 2x times 4. The 2 goes into the 4 2 times, and I'll have 2 times 5, which is 10, times x, plus 25 over 4 times 4, and that'll just be 25. And 0 times 4 is 0. Solving that equation is equivalent to solving the original equation, because I have the same equation. I'm allowed to multiply both sides by the same number. So let's find the discriminant of that equation. B squared minus 4ac would give me negative 10 squared minus 4 times 1 times 25, which equals 100, minus 100, which is 0. What happens when my discriminant is 0? Well, that means I have one double real root. So let's find out what it is. When the discriminant is 0, I can factor. It's because 0 is a perfect square. So I can factor this. I find factors of 25 that will add together to give me negative 10. About negative 5 and negative 5. So I'll have x minus 5 times x minus 5. Or x minus 5 squared equals 0. Either way I think about it, it means x minus 5 equals 0, so x equals 5. And that number would show up twice. So it is a double root. The way I write my solutions is just as the solution set containing 5. That is the only solution I have. It just happens to be a solution twice. So that's what happens when the discriminant is 0. One double real root. So here are your immediate practice problems. 3 problems, 3 quadratic equations. You need to solve them using any appropriate method. If it's factorable, feel free to factor it. If it's not, either complete the square, use the quadratic formula, and state your answers as solution sets. And that is the end of section 7.2 and 7.3.